in the last class, we gave examples of sorts. We said examples of sorts are prime numbers under root, like 2 under root, that is root 2, root 3, root 5, root 7, root 11, root 13, and so on. We said they are sorts. But what about if we have some other numbers that are not prime numbers under a square root? Will they be sorts too? Yes, they'll be sorts, but we have to simplify them, and that will lead us into simplification of sorts. Examples. So if we have simplification of sorts, if we have this root 8 and we are to simplify it, how do we do it? We write the numbers that multiply together to give us 8. I will suggest that you should just get a rough sheet, write 8, and try using prime numbers to divide 8. The smallest prime number is 2. So how many 2 can we get in 8? 4. Then how many 2 in 4? 2. How many is 2 in 2? 1. So that means 8 is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 2 times 2 times 2. So pair those that are the same. So you have only 1, 2 left. The one you have paired, just take one out of them, put it outside the square root, and the one that is remaining, let it be. What I did is that 2 times 2 is 4, and the square root of 4 is 2. And the 2 that cannot be paired, the one that is single, is still remaining under the square root. So you can see that if we say root 8 is a sort, by the time we simplify it, we are still going to get something like this, which is a whole number and a prime number that is under a square root. Another example, if we have root 27. So get a rough sheet, 27. 2 cannot go in 27. 2 cannot go in any number that is not ending with an even number. 7 is not an even number. An even number is a number that can be completely divided by 2. 7 cannot be completely divided by 2. 2 can completely divide 6 to give 3. But 2 cannot completely divide 7. There will be a remainder of 1. So 27 is not an even number. But 3 can go in 27. Maybe I should just give you a clue on how to know whether 3 can divide a number. 3 will divide a number completely if the addition of the digit of that number, like 27 in this case, 2 plus 7 gives 9. If the answer you will get after adding the digit of the number will give you a number that can be completely divided by 3, then 3 will go in that number. So 3 can go in 27. So if you use 3, I use 3 because 3 is the next prime number. Since 2 cannot go, then I will try 3. 3 in 27, that's 9. 3 times 9 is 27. Then 3 can still go in 9. 3. 3 can go in itself, 1. So 27 will be 3 times 3 times 3. So when you pair, so you are going to have the ones you pair, take 1 out, and the single 3, leave it under the root. So I have just simplified that. What about if you have a number like root 24? So square root of 24, if we are to simplify it under sorts, get a rough sheet, 24. Use the smallest prime number, which is 2, to divide it. Can 2 divide 24 completely? Yes, because it's an even number. An even number is a number that can be completely divided by 2. And we know 24 can be completely divided by 2 because it is ending with 4, which is an even number. So 2 in 24 is 12. Can 2 still divide this? Yes, because you can see 2 here. So 12 is an even number. So 2. 2 in 12 is 6. Can 2 still completely divide this? Yes, because 2 can divide 6. So 2 in 6, 3. 2 can no longer completely divide 3. So we are going to skip 2 and go to the next even prime number, which is 3. So we have 1. So we can write root 24 as 2 times 2 times 2 times 3. So here we need to pair. So we can only pair this, we can't pair this because they are not the same. So in this case now, please just get it right. That 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. We get this 24 back. So the one you have paired, take 1 out of it, and the rest that cannot be paired, just multiply them together. So 2 times 3 is 6. So the final answer is 2 root 6. So that is how we simplify surds. So classwork, solve this and type in your answers for number 1 and number 2 in the comment section. So simplify. Number 1, square root of 32, and number 2, square root of 54. So write your answers for number 1 and 2 in the comment section. This is Math Made Simple by Steve. So, and don't forget to like, share, and subscribe. So God be with you.